Alright, so we are going to learn about kinetics, elementary steps, and mechanisms. So we're going to start out with what is an elementary step? Well, an elementary step, or otherwise known as an elementary reaction, is a chemical reaction in which one or more of the chemical species react directly to form products in a single reaction step. And therefore, a mechanism is a combination of one or more of these elementary steps. So we're going to start out with an example that doesn't have much to do with chemistry. So say we have a team of 3 track runners, and they start, and the first runner is holding a pink baton. So he must run and pass the baton to the second runner before the second runner can start, and the second runner must run and pass the baton to the third runner, and the third runner can't start until he has the baton from the second runner. So each runner in this race represents an elementary step, and the combination of the 3 from start to finish represents the entire mechanism. So we're going to start out with talking about molecularity. So molecularity is the number of molecules coming together to react in the elementary step. So a unimolecular reaction is a single molecule shakes itself apart or shakes its atoms into a new arrangement. And so an example of this is this orange and yellow molecule, which then separates into a single orange and single yellow molecule, which is represented by A goes to B plus C. There can also be a bimolecular reaction. In a bimolecular reaction, 2 molecules collide and exchange energy, atoms, or groups of atoms. So an example of this is an orange molecule collides with a yellow and pink molecule, producing a single yellow molecule and separate orange and pink molecule. And this can be represented by A plus B goes to C plus D. Alright, so we're going to look at more examples of elementary steps and reactions. So example 1. This example has 2 separate elementary steps. So in the first elementary step, A plus C goes to B. And in the second step, B then reacts with D to give E plus C. And our overall reaction, after we cancel everything out that appear in both the reactants and the products, is A plus D gives E. So in this example, B and C get crossed out, and they represent different things. So C is a catalyst because it is used up in the reaction but then gets produced at the end too. And B is an intermediate because it is formed in the first step and is then used in the second step. So there's our first example. In our second example, A plus B react to give C plus B. And in the second step, C plus A give D. The overall reaction mechanism after canceling things out is 2A gives D. So in our first step, B is a reactant and also a product, and that, even though it gets crossed out, that is fine because B needs to be present in order to form C also. And then C is also an intermediate because it then gets used up in the second step. Okay. Now moving on to our third example. So this one has 3 separate elementary steps and reactions. The first step is A plus B gives C. The second step is C plus D gives E plus F. And the third step is A plus E gives B plus G. So after we cross everything out, our final reaction is 2A plus D gives F plus G. And so that's our whole reaction mechanism. And in the mechanism, B is a catalyst because it gets used up in the first step and is then produced in the third step. And C and E are intermediates because they get produced and are then used up in another reaction. So, moving on. Oops, sorry about that. So, an elementary step means that we can derive the rate law from it. And so we're not going to talk about rate laws in depth because that will be in another video. But we can deduce rate laws from our elementary steps. So one example of this is A plus B gives C, and our rate law for this elementary step is the rate equals Kr, the constant, times A times B, the reactants. And so therefore, if we have a unimolecular reaction, that will be first order since a unimolecular reaction has one reactant. And so in this, A gives you B plus C, and so our rate law is then the rate is Kr times A. And finally, if we have a bimolecular reaction, that will always be second order since we have two species reacting with each other. So A plus B gives you C, and then our rate is rate times Kr, the concentration of A times the concentration of B. So that is the main concepts of elementary steps in mechanisms in kinetics. And yay, kinetics! Kinetics is fun! That's it. Hope you all learned something.